So again, happy Friday, everybody. Happy Friday. 3-day weekend Friday. These are one of the best Fridays, right? The 3-day weekend Fridays. Those are some of the best Fridays. They're just different. Some of you didn't even realize it was a 3-day weekend. So yes, good surprise. So let's see some of your answers. Okay, here we go again. Technical difficulties. Okay, let's see if this works. Yes. Okay. There we go. No. Okay. So here are some of your answers. As he is rotating, the points are changing. Yes, that's true. I asked you to be specific, but that's okay. Each point is reversed in some way. Yes, they are reversed in some way, like how the thumb is right now. It can be reversed as in position or the number itself or both. See, that's very vague, right? That's very vague. You're on the right path. You guys are on the right path, but that's not specific. I wanted you to tell me, look at that. That's 4, -2. What happened when I went 90 degrees? Tell me what you think. Tell me what you think. That's what I was looking for. So it's okay. It's a warm up. We'll get to it. Right? Sometimes it takes us a little time to warm up. Mario is turning counterclockwise around the origin when the image turns. Okay. Mario is being reflected. No, remember we talked about he wasn't reflected because reflected means he would be facing the other way. So he's not being reflected. He's being rotated. If he was reflected, his nose, kind of look at his nose. His nose would be facing each other, right? And his face would be facing each other if he was reflected. So we agreed yesterday that he was rotating, right? And it's okay. It's okay. As Mario is rotating on all 4 quadrants of the graph, the point on his thumb, which consists of 4 and 2, constantly change positions and signs. Yes, we know that. How? That was the question. How is it changing, right? It's okay. Again, this is a warm-up, so we're warming up to it. We will get to it. It's as if the X and Y switch places. Do they? They do for 90, right? So if we look at 90, so I finally find something that's specific. They switch places, right? The 4 and 2 kind of switch. It's as if the X and Y switch places, and one of them, which one? One of them. Why are you guys so vague? You guys it's like very mysterious. You guys like to be very mysterious, right? Becomes either negative or positive, and it's being rotated but never really changes into any other number except 2 and 4 and their counterparts. I guess you mean your negative and positive. Yeah. So that's exactly what I was looking for. We all noticed that yesterday, right? They're all 2s and 4s. So that's what I was looking for. I'm looking for a specific. How are they changing? So I got a little bit of it. It's okay. This is how it's kind of like we're trying to solve a crime, right? And that's the crime scene photo. Again, we're detectives, right? We're always detectives. And it's kind of like we're a whole bunch of detectives right here, and we're going around the room. What do you think? What do you think? What do you think? And everyone's giving up their opinion. And little by little, we'll get some clues. So this person said the X and Y switch places. So that's one thing that does happen. Okay. What is happening is that the point always moves 2 points in a direction each time we rotate the figure. It moves 2 points in a direction. What's a direction? What direction? Each time we rotate the figure. Okay. The coordinates flip. Yes. Okay. So we have the flip. They have changed places, but he is rotating 90 degrees. Yeah. He's rotating 90 each quadrant, right? The numbers change their position and sign. Okay, how is what I'm looking for. It is rotating counterclockwise when it's at -4, 2, and it's turned 90 degrees. The points, they didn't finish. The points what? Dun, dun, dun. Very mysterious. As he rotates, the number consists of 2s and 4s. Yes. And then what? The coordinates flip every time, and sometimes it's a negative or no negative. So if they flip every time, so if we look here, from here to here, they switch places, and one of them changed signs. And then from here to here, they switch places, and one of them changed signs. From here to here, they switch places, and one of them changed signs. And then from here to here, they switch places, and one of them changed signs. Okay, so we're getting a little somewhere. We're getting closer. So every time we rotate 90 degrees, they flip places, and one of them switches signs. Okay. They make a square with a rotation. Mario's thumb is always the y-axis. What do you mean Mario's thumb is always the y-axis? It has x and y coordinates, right? Mario's thumb has x and y coordinates. So I don't know what you mean by that, but it's okay. The number switch as he's rotating. The thumb is going 90 degrees counterclockwise. Well, the whole thing is, right? We're just focusing on the thumb. Make sure you're clear on this. The whole Mario's rotating. We're just focusing on a thumb because it has a point, and we're trying to get the coordinates of that point, because maybe that point will give us a clue on what we need to do for all the points of Mario, right? So we're just focusing on one, but the entire Mario is rotating. We're just focusing on one point to see if we notice a pattern, because that's the whole thing with math, patterns. His thumb is going 90 degrees counterclockwise, and in doing so, the numbers switch from 4, -2 to 2, 4 in the first rotation of 90 degrees. But if we were to do a 180-degree rotation, it goes from 4, -2 to -4, 2. Oh, so now this person's saying, okay, you know how we've been focusing on what happens as we go 90? This person says, okay, that's what happens when we go 90, but look what happens when I go 180. They stayed in the same position, but they just switch signs. So if we go 90, so this is what we noticed so far, what you guys have put pieced together as detectives, all of us detectives together. As they go 90 degrees, they flip, and one changes signs. Every time we go 90 degrees, that's what happens. They switch, and one of the signs change. This person said, oh yeah, but if we go 180, they stayed in the same spot, 4 and 2. They just got opposite signs. Okay, so now we have two things going on, either 90 or 180. They are relatively in the same place as it's being rotated around the graph. The numbers switch from negative to positives, and they even change their axis. Okay. They are the same distance from each other. So if I did that, and that, and that, and that, right? And it makes sense because that's 90 degrees, 90 degrees, 90 degrees, 90 degrees. That's a square. Yeah, good job. It is going counterclockwise direction. The quadrant grows. When you rotate, it forms a cube. Actually forms a square, but yeah, I get what you're saying. Cube, square, same family. All right, so we didn't get anyone give us exactly what's going on, which is okay, because maybe you don't understand exactly what's going on, but you kind of can see it though. I mean, everyone's on the right path. You're right there. Numbers are the same, but they change position or they change signs. And then some of us said, okay, 90 degrees, they change position, and one of them changes signs. Which one? Can we focus on which one? So when I look here, they change position, and it looks like the 2 changed signs, right? Looks like the 2 changed signs. Let's see. So it looks like the y from the first coordinate changed. And then when we go here, is the same thing happen? So that means the y from this coordinate is going to change. And if we look here, yeah, when I switch them, that y coordinate from the first point changed signs. Ah, now we're starting to see a pattern here. So they switch places, and the y changed signs when it gets to its new position. Just that one. And if we notice 180, if we go from here to here, they stay in the same position. But they both change signs. So if we look here and here, the 4 becomes -4, the -2 becomes +2. Right? Does it happen here to here? Let's see. If I go from here to here, they both stay in the same spot, but they both change signs. So there must be a rule here. There must be a rule here. So let's do that. Let's look at our notes from yesterday. So everyone take out your notes. And let's see if we can come up with the rules of what happens. Rules for what happens when we rotate. Okay. So I know we looked at one point. You guys want to test another point? Like if we do the button right here, If we do the button, let's do his button. His button is about 4, -4. Oh, it's the same one. See, that's kind of tough because it's 4, -4. How about, let's look for another one. Let's see. I'm trying to look for a point. Well, if we look at his nose, that's 4, -3. Well, that's, I want it to be a little bit different than what we were looking at. I don't want 4s in there. Let's look at, you see this right at the tip of his glove. If you look here, you guys see how there's 3 things right here on his glove. Let's focus on that top one, right? So if we look right here on his glove, oh my God, those are 2s and 4s again. Oh my God, I don't want 2s and 4s. Okay, how about the bottom of his boot? How about the bottom of his boot? Oh my God, that's 5, 5. We don't want to have the same number. Mister, pick a point. I know, I'm trying to pick a point that's not the same. I want it a little different. How about his armpit? No, that's a 4. We still have a 4 there. His left boot. If we look at his left boot, so if we look right here, right in the center of his left boot, right? That's 3, -6. So someone said his left boot. Okay, those are 2 different numbers, 3, -6, right? So we're looking right at that point right there. So his left boot. So if we look over here, that's right there. That would be 6, 3, right? 6, 3. Okay, and then let's look at his left boot up here. Right there, it's -3, 6. Right? If we look there, it's -3, 6. And then thank you for the suggestion. Thank you for the suggestion. This left boot kind of works because we have different numbers. I did not want to have 2s and 4s. I wanted to do different numbers. So if we look at his left boot right here, we have -6, -3. Okay, you guys see that? -6, -3 to get to that point. Okay, so is the same thing happening? Let's look at the boot. We have 3, -6, and we go 90 degrees. It goes 6, 3. So they switch. The X and Y switch. And the old Y, right? The old Y, which is the new X, changes signs. So maybe we can put that as a rule. So when we rotate 90 degrees, we can say, how can we say this? Each point the X and Y switch, and the old Y changes signs. Okay, let me write that a little neater. It's a little chicken scratchy. I'm sorry. So I'm going to say this again. So how can we say this? Each point. So we're describing what happens when we rotate 90 degrees, right? So we're describing, so those of you that are lost right now, what we're doing is we're describing what happens to each point when I rotate just 90 degrees. And we can see for both of these, the red and the purple point, the boot and the thumb, that the X and Y switch, but the old Y, this is the old Y, which becomes the new X, changes signs. The other one stays the same, right? The old X or the new Y stays the same. So I'm trying to describe that in words. And then I'll show you how we can, oh, we never wrote the top part. Oh, you're right. Okay, so you want to come back to this? Someone's telling me, Mister, we never did the top part of the notes. You are absolutely correct. So let's put a pin in this, right? We'll come back to the 90 degrees. Let's fill out this top part. This is just a definition. And so let's do that. I'm sorry. We did that in 14th period. So in period 14, we didn't do it here. So I'm sorry. So let's define what a rotation is, okay? So before we move on and describe the points, Let's describe what a rotation is. A rotation, and we're looking at the easiest rotations here. The rotation about the origin, meaning the origin is the center. And about just means around. I don't know why geometry wants to get fancy and they want to talk. It's about the origin, right? It's around the origin, right? Just about just means around. So we're rotating around the origin. So you have to imagine this figure, ABC. We are rotating it. We are rotating it 90 degrees. And you got to imagine a string. Imagine here's the origin's the center, right? Imagine a string. I put a string on C. And then I swing that around. I put my finger on the origin. I put my finger on the center. And then I rotate it 90 degrees. And that's what it looks like. And then I do the same thing with B. I draw a string. And then I rotate it over here. And the string is still there. It's the same length. And you can see that 90 degrees, right? You can see that 90 degrees. And then I do the same thing. Nope. I do the same thing with A. I put a string from the center to A, and I put my finger down on the string in the center, and then I get A, and I swing it around. I swing it around right here, and the string's still down here because my finger's still on the center, and then that's how you see that angle there. Okay, so that's a rotation. Okay, that we're rotating, and we're just doing the easy ones. We're rotating where the origin, the middle of the XY axis, the origin is the center. Okay, we could have it different places, but that's a little more difficult. We're just going to focus on the easy ones, right? So here's our definition. Okay, a rotation is a turn around a fixed point called the center of rotation. And our center of rotation is going to be the origin. That's what we're going to focus on because that's the easy one to look at for right now. Okay, so a turn around a fixed point called the center of rotation. And our center of rotation for these notes are going to be the origin, the center, right? The middle. Okay, so the figure rotates at a specific angle and direction, right? Angle. And what angles are we going to use? We're going to use 90, 180, and 270. Those are the only three we're going to look at. 90-degree rotation, 180-degree rotation, 270-degree rotation. Right? And then direction, what direction are we going to be looking at? We're usually going to go counterclockwise. That's going to be our go-to direction. 360, it takes it to the same place, right? I mean, we can rotate something 360, but we'll be in the same spot. The points will not change, right? If I go all the way around, the point is in the same place. So 360s, I mean, we could do 360, but those are easy. Yes, I can zoom out. Sorry about that. There you go. And though the figure can rotate around any fixed point, the most common center of rotation is the origin, and that's what we're going to focus on. Okay, that's what we're going to focus on. Okay, so that top part, I'm sorry. Yes, I did skip over it because I thought we went over it, but we didn't. That's just a little definition of what we're doing. A rotation is called a turn. Remember, translation was called the slide. A reflection was called a flip. A rotation is called a turn, like you're turning a knob. Okay, so that's the definition. So now let's get back to what we were doing. I want to describe what happens to each point. So that's what we're looking at, each point, because if we can figure out what's happening to the points, we can, if we get a regular figure like a square or a triangle, we can just get the edge points or the corner points, the vertices, and just rotate those a certain way if we're going 90, 180, 270. So for 90 degrees, we agreed each point the X and Y, hold on, let's get the right color. The X and Y coordinates switch places, and the old y changes signs. Okay, that's the way to say it in words. So if we're saying this in words, for each point, we can say for each point, the x and y coordinates switch places, and the old y changes signs. I'm going to show you a way to do that and to not do it in words. So let me show you. We say x and y, so let's do it in red, so it sticks out a little bit. So we have x and y, that's our original point, is going to turn into, right? This means turned into, the x and y switch places, right? But this first one turns negative, turns opposite. So that's basically what's happening. The x and y switch places, but the old y turns opposite. That's what when you put negative in front of something, that just means it's opposite. Okay, does that make sense? So if I want to turn 90 degrees counterclockwise, the point, the x and y, are going to switch, but the old y, or the new x, turns opposite. And we saw that with Mario. That's exactly what happens. Right? That's exactly what happens. This x and y switched places, and then this old y turned opposite. That -2 turned into +2 when it came over here. It happens every time. Look at this perp right here. 6, 3. 3, -6. But look what happens to the 3. That turns opposite. Right? Happens every time. If I go right here to right here, they switch places, the 2 and 4, and the old y, which is 2, turns into -2. So that's our description when we turn 90 degrees. Yeah, the video is this, right? This is the video. We're making the video right now, and I will put it up after class so you can look at this again. Yeah, somebody asked in the chat, guys, if I'm going to submit this video, and yes, the video of today's lesson will be there. Video from yesterday's lesson should be up there too. If not, I'll double check. All right, let's look at 180. What happens when we rotate 180? So let's start with his thumb. Right? Look at his thumb. And somebody kind of described it. His thumb goes here to here. So what happened? Did they switch places? Did the x and y switch places? No, they actually stayed in the same place. The 4 and 2 stayed there. But what happened to the signs? The signs turned opposite, didn't they? The 4 became -4. The -2 became +2. Let's see if that happens every time. Let's focus on let's look at his boot right here. 6, -3. 6, -3 turns into 6, 3. Yeah, they both of them are negative, and now they're both positive. Okay, let's look here. 2, 4 turned into -2, -4. So that sounds easy. So when I rotate 180 degrees, let's do it in words first. When I rotate each 180 degrees for each point, the x and y coordinates do not switch, stay, but both change their signs. Okay, and so if we want to talk about it, so we have our original point, and it changes to, this arrow means changes to, it changes to the opposite. So the x becomes -x, and the y becomes -y. And so that's what happens. Okay, so when we rotate 180, the numbers stay in the same spot. The x and y don't switch, but the signs change, each one. Okay, Any questions about 90 and 180? That's what we see is happening. So for 90, they switch places, and that old y turns negative. For 180, they stay in the same spot, but both of them just change their sign. Okay, and then let's lastly see what happens at 270. We actually didn't talk about that from what we saw in the warm-up. Hold on one second. Sorry about that, guys. My son showed up. And they just wanted to say hi really quick. Okay, so, all right, so what happens when we go 270? What happens when we go 270? So if we look here, let's focus on his thumb again. So we go from here and we go 90, 180, 270. So what happened? Well, they switch places. They switch places, but now, so they do switch places, but which one turned opposite? The old x turned opposite. You see that? The 4 turned into a -4. So it's kind of like what happened here when I did 90. They do switch places, but the old x changes signs now. The old x. Let's see if that happens again. Let's try it with this one. 6, 3. And we go all the way around 90, 180, 270. So that means it goes 3 quadrants. And they switch, the 3 and the 6 switch, but the old x, you see the old x is 6, the old x turns into -6. So it's very similar to what happened to 90. So let's put that in words. For each point, the x and y coordinates switch places, and the old x changes signs. So how does that look like when we say old point, x and y changes to, that's what that arrow means. Arrow means changes to. So the y and x switch places, but the old x turns negative. There you go. Those are the rules. Thank you, Mario. Yeah, the old x now. The old x now. All right, so those are the rules. For rotating counterclockwise 90, 180, 270. Okay. And this is all we need to know. This is all we need to know. So if we get stuck, if we're doing a problem, we say, wait a second, what happens if I'm rotating 90 degrees counterclockwise? What do I need to do? Look at this chart. So this is the chart that's going to help you for the entire section that we're talking about, all about rotations. If you know this, and do you have to memorize it? No, because you can use your notes. Any quiz or test or homework, you can always have your notes next to you. So you don't have to memorize it. If you want to, you can. You don't have to, though. And then understanding it, well, mister, I don't understand. I don't understand what's going on. Well, go back to Mario, and then that's where you can see how we figured this out. We looked at 2 different points. We looked at his boot, and we looked at his thumb. And then we looked for patterns, and we saw the same pattern happening over and over again. Okay? Now, someone asked, can we stop here? I do want to do one thing. Okay, I'm not going to move a whole figure. I want to move just 1 point, and then we'll see if we can do this. So, number 1, we need to move triangle ABC. I don't want to move the whole triangle. I just want to move A. Let's just move A for right now. Okay, 2, 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. So there's A. Okay, and it's 2, 7. I need to rotate it. What does it say? Rotate 90 degrees counterclockwise. So we're going to go 90 degrees. So what happens if I want to get A prime? A prime is going to be what? It's going to be A, but I'm going to do something to it. So let's go back. What do I do to it? It switches, and the old Y becomes negative. So let's see if we can do that. It switches. So that means the 7 comes over here, and the 2 comes over here. And then which one's the Y? Which one's the old Y? 7 is the old Y, so that becomes negative 7. And so let's plot that. 1, 2, 3, 4, 5, 6, 7, 1, 2. And there's my A prime. Okay, and then we would do that for each point to get our new triangle. Okay, we're going to stop here. We will stop here for now. We will continue on Tuesday. We will continue on Tuesday. What do you mean? Oh, I did. I did. Thank you. Someone said, Mister, you put them in the wrong spot. I did that on purpose. Let's look at the point. The point says what? The point says what? Negative 7, positive 2. You're in the wrong quadrant, mister. Good job. Good job. 1, 2, 3, 4, 5, 6, 7, positive 2. Positive 2. There's A prime. Not this one. Thank you. Thank you. So that's A prime. Negative 7, positive 2. Okay. Sorry about that. Thank you. Very good. Someone's paying attention. Someone's paying attention. And it makes sense. When you're rotating 90 degrees, it should go from one quadrant to the other quadrant. It should not go 2 quadrants, right? 90 degrees means it should only go into the next quadrant. 180 degrees means it should go in 2 quadrants away. 270 means it should go 1, 2, 3 quadrants away. So if you're going 90 and it's over here, you did something wrong. Okay, does that make sense? Okay, we will continue this next time, but enjoy your 3-day weekend, guys. Enjoy your 3-day weekend, and take care. And I will see you all Tuesday.